Today we're going to learn what a manifold is, what it does, and how to install it. A manifold is able to provide multiple functions. Its main job is to distribute hot water from a central location within your house. With every run of pipe, it only has a certain amount of distance it can go before the hot water starts turning cold. This means trying to use one pipe run to heat the entirety of your kitchen floors will start off hot where the run is closest to the water heater and end up cold by the time it gets back. This is a very inefficient way to perform radiant heating. That's when we look to manifolds. Rather than having one length of pipe trying to cover a big area, a manifold will be able to split the water, allowing it to be individually fed to multiple runs of pipe. Not only does this make the heating and water distribution much more effective, but it also provides more and safer options. For instance, if a pipe were ever to rupture or there was a fitting that came loose, rather than turning off the water for the entire system, you can simply close down the one run of pipe directly at the manifold. When you're looking for manifolds, you'll find a lot of different options from PVC, copper, to steel. They have almost any option you're looking for, whether it's a manifold with 4 circuits or ports to run lines on, all the way up to manifolds with 10+ circuits. Our manifold here has the standard 1-inch screw-on connections. On the top, we have an automatic air vent. On the bottom right side, we have the drain connection. We have temporary decorator caps on the top rail. They are used for isolation and adjustment of each circuit. There is an option to replace them with electronically controlled actuators. The actuators allow the user to control each room or run of pipe temperatures individually. The flow indicators on the bottom of the manifold give a visual gauge as to how much water is flowing through each circuit. The amount of flow needed depends on the length of the circuit and the amount of temperature drop needed. As a rule of thumb, the shorter the circuit, the more restriction that will be required. This is how you balance the system. To adjust the flow, take off the locking ring at the bottom of the meter, then turn the adjusting nut. We also need to install a mixing valve. If you were to put hot water straight from the boiler to the radiant heating, it would be too hot for the floors and start turning into a game of the floor's lava. This will connect to the flow and intake lines, mixing the two to the desired temperature. When you're deciding where your manifold will go, you want to choose a location that is as central as possible to the circuits. Make sure you allow at least a couple of feet off the ground to accommodate the piping runs. Once you have mounted it to the wall and have connected all your piping, it's time to fill it. Since there's a larger quantity of pipework than a normal system would have, be sure to follow all the piping procedures in the manual as closely as possible to reduce the amount of air let into the lines. If there is too much air, that can lead to testing and operational problems. Now, open all the gauges at the bottom of the manifold, remove the locking rings, and open the valves all the way by turning them counterclockwise. Connect the fill point on the bottom to a hose pipe and the top connection to a bucket or drain. Something you want to be aware of is that it's important that the water is forced around the UFH loops one at a time. This prevents short-circuiting from one manifold rail to the other. Close all the decorator caps on the top to shut off all the circuits. Once they're all shut, open only the farthest one all the way. Now turn on the water, allowing it to go through the whole loop. In doing so, it will be flushing the air out with it. Now, close the cap and move on to the next one, repeating the process until all are flushed out. Each one only needs to run for 5 to 10 seconds or so. When you're finished, shut off the top drainage valve, then turn off the water supply and shut off the bottom valve. It's ready for pressure testing now. To test the system, shut off all the ball valves, then open all the flow gauges on the bottom by removing the locking covers and turning anti-clockwise again. Same goes for the decoration covers, make sure they're all open fully. Connect a pressure testing kit to the fill valve. While the valve is open, pump the pressure up to 2 bar. Now leave it there for 10 to 15 minutes to see if there's any pressure drops by the time you get back. If it hasn't dropped, then pump it up to 10 bar and leave it again for 10 minutes. If it stays strong at 10, then you can drop it down to operating pressure between 1 and 1.5 bars. Note, set the pressure to 6 bars while you're laying it down underneath screeded floors to prevent damage or collapse in host structure. Once it's been laid and dried, you can go back down to operating pressure. There's a few different screeds you can use: sand, flowing, or cement. Be sure to pack in the screed around the pipe runs. Typically, you have to wait around 28 to 30 days before you can start heating the new radiant flooring. But if you do happen to use a calcium sulfate screed, it may be allowed to heat up after 7 days of sitting. Turning on the radiant heating before the screed is dried will not help it dry quicker and can lead to much bigger problems. Be patient, let it dry, and then you can use it happily without concern. If you are placing the piping down in freezing conditions, then fill the lines with an appropriate antifreeze. Once everything's installed and ready for use, flush out the system to replace the antifreeze with water.